All right, so today I want to talk about a property. Most of the time, this property is shortened. Most of the time, you'll hear people simply call it the distributive property. But the actual name of the distributive property is the distributive property of multiplication over addition. And that addition actually implies both addition and subtraction. I'm going to go ahead and show you some examples here. I want to show you two different models. On the left hand side, I am showing a very algebraic model here where often we will see it in an algebra class. On the right hand side, I'm showing you what we consider an area model, connecting this to an area. So here in this scenario, you'll notice the first thing I want you to notice is that I have 10 with a set of parentheses and then 4 plus 5. One of the ways that you could do this if you were simply solving, thinking about simplifying this by using order of operations, all you would do is add the 4 and the 5. That would give you a 9, and then you multiply 10 times 9, you get an answer of 90. Everybody agrees that the answer is 90. But instead of us actually putting those numbers together first, I want to use this kind of as an example of how we could use the distributive property. So what I want to do is I want to give this 10, I'm going to multiply that 10 to the 4. So 10 times 4 is going to give me a 40. I'm going to go ahead and put that 40 right below the 4. The next thing I'm going to do is I'm going to copy down this positive, the plus sign that's in between there. The second thing I want to do is I want to distribute the 10 to the 5. And when I do that, 10 times 5 is going to give me 50. Now you will notice that if I add these two numbers up, obviously at the end I'm going to get an answer of 90. Okay. If I take a look at the area example here, once again, if I had a rectangle that had a length of 10 and 4, 10 times 4 would give me an area of 40. So that rectangle there would have an area of 40. Likewise, if I multiply the 10 times the 5, that would give me an area of 50. If I looked at the total area, how much was their total? 40 plus 50 would also give me 90. Okay, so in this second scenario here, I've removed all of the numbers, and now I've actually included some variables here. So on the left-hand side and the right-hand side, I actually have the same equation. Once again, one with an algebraic model, and the one on the right-hand side with an area model. I wanted you to see both of these, and whichever one is familiar with you or more comfortable, you can go ahead and use. So once again, on the left-hand side, what I want to do is I want to multiply the 3 times the x. When I multiply times 3 times x, I'm going to get a 3x. Next, I want to copy down that minus sign. There's a negative sign there. The second step I want to do is I want to multiply the 3 times the 4. 3 times 4 is going to give me 12. And you'll notice here that my simplified version of this is 3x minus 12, my answer. Likewise, on the right-hand side, if I were to multiply 3 times x here, I would get 3x in this scenario. And if I were to multiply 3 times negative 4, I would get negative 12 in that box. So once again, you recognize that these are the same. Okay, so in this last scenario here, I wanted to show you what it would look like if I actually had to distribute a 5 to actually 3 terms. The distributive property actually can go across as many terms as needed as long as they're all within the parentheses. And so the first thing I want you to show is that when I multiply the 5 times the 2x squared, I'm going to get 10x squared. In the second situation here, I'm going to multiply 5 times negative 4x. A positive times a negative is going to give me a negative. 5 times 4 is going to get me 20x. And the last scenario is going to be 5 times 3. 5 times positive 3 is going to give me a positive 15. Okay, in this final example here, I want to show you kind of something that looks a little bit odd, but you actually bump into this quite often. You'll notice in front of the parentheses here, the only thing that I have is actually a negative sign. There actually is a negative 1. It is implied there. There it is. There's a negative 1 right there. We don't write that negative 1, and so what I'm going to simply do is erase that negative 1. But what we want to need to actually consider is that there is actually a negative 1 there. So when I go ahead and distribute this, I'm going to distribute the negative sign to the 3x squared, and that's going to give me a negative times a positive, which is going to give me a negative 3x squared. The second situation is here when I go the negative to the negative 8. A negative and a negative is going to give me a positive 8. I hope that this this is going to wrap up the rest of my video. I hope this video helped you out understanding the distributive property. I hope you have a great day.